In chapter 3, we're going to be graphing linear equations. That means graphing lines. But before we do, we have to talk about the rectangular coordinate system. The rectangular coordinate system is a scheme that is used to identify points in space and the location, actually, the location of points in space. And what we deal with in this course is a plane, a plane, which is formed by two intersecting lines. So two number lines that are intersecting each other at right angles. One number line is a horizontal one, and we call it the x-axis here. And the vertical number line is the y-axis. They intersect at at one point called the origin. And the origin is 0 on the x-axis and 0 on the y-axis. So it's where everything is referenced from. The origin is the reference point of the rectangular coordinate system. So we have an x-axis and a y-axis. Both of these are number lines, which means they go infinitely in the positive direction and in the negative direction. The positive x direction is to the right. Anything moving to the right of the origin is positive on the x. To the left of the origin is negative. On the y-axis, above the origin is positive, below the origin is negative. Those two lines, x-axis and y-axis, separate this plane into 4 quadrants. Quadrant 1, we always label the quadrants with Roman numerals. Quadrant 1 is always the upper right-hand quadrant. This is something you're going to have to know. Quadrant 2 is counterclockwise. You're moving counterclockwise to continue numbering the quadrants. Quadrant 2 is the upper left quadrant. Quadrant 3 is the lower left quadrant. Quadrant 4 is the lower right quadrant. Okay? Now, on the diagram on the right, we're going to talk about how to locate points or to name those points after we have located them on the rectangular coordinate system. Every point in a two-dimensional coordinate system has to have 2 coordinates. Co meaning go together, 2 coordinates. The origin, what we talked about, has a value of 0 on x-axis and a value of 0 on the y-axis. So what that means is that the origin has a coordinate pair, an ordered pair of 0, 0, where the x value is always written first, the y value is always written second, separated by a comma. Okay, and the origin is 0, 0 on our coordinate system. Any other point in our coordinate system will have a different x value and y value from the origin. So look at this point here. I'm pointing my pink arrow to it. In order to move from the origin to this point, we have to go to the right 3 spaces. That means in the x direction, positive x direction, 3 spaces. Then up 2 spaces, which is positive in the y direction. So that's why the ordered pair that names that point is positive 3, positive 2. And we drop the point right there. The other point that's shown here, over here on the left side, in order to get there from the origin, everything is referenced from the origin. We have to move 2 places to the left on the x-axis, so that's in the negative direction, and then move up 5 spaces to get to that point is a positive 5. So that point is negative 2, positive 5, and that's how it's labeled. It's very important that you understand that every point that we're dealing with has to have an x value and a y value. And you always list the x value first and the y value second. Now we're going to write the points that belong to each quadrant or each axis. Very quickly here, we want to locate points in the first quadrant. Well, where is the first quadrant? Up here in the upper right hand corner. The points there are A, S, F, and D. Quadrant 2, we have B, H, M, N, and W. All of those are in the quadrant. If they're on an axis, they're not in the quadrant. They're on the axis, so we have to keep that in mind. Quadrant 3, C, Z, J, I, and P. Are all in quadrant 3. Quadrant 4, we have T, R, Y, U. T, R, Y, and U. Now, on the x-axis, be careful. We have V, K, and E. V, K, E. And on the y-axis, we have G, Q, and L. So all we did was identify where these points are, what quadrants they are in. Okay? We weren't asked to name them or to give them coordinates, but we just asked to find what quadrant or axis they are on. Now we're going to plot some of these points and coordinate points below. I'm not going to do all of them, just going to do some of them. So I want to plot -4 and 10. That means starting at the origin, I want to go -4 in the on the x-axis and +10 in the y direction. So that means I'm going to plot the point up there and get into the habit of labeling your point when you plot it. Then I want to do, so that point is in what quadrant? Second quadrant, okay? So 7 and -9. So that's 7 in the right, in the positive x. -9 means down in the y, on the y direction. 7 and -9. What quadrant is that point in? It's quadrant 4. Let's do -4 and -6. So that's a -4 and -6 down here. And let's do 6 and 5. 6 in the x direction, 5 in the y. Let's do 0 and 9. 0 in the x direction means you're not moving at all from the origin. You're not moving left or right in the x direction, but you're going to move up 9 spaces. So this particular point is on which axis? It's on the y-axis. So one thing you can notice, I'm gonna make up a point here. I'm gonna do 3, 0. And I'm gonna plot it. 3 and 0 means 3 in the x direction and 0 in the y. I'm not moving up or down. So that's 3, 0. What I want you to notice now, every point that's in the first quadrant, the point will have a positive x and a positive y value. That's what this means, a positive x and a positive y. In the second quadrant, the point will have a negative x and a positive y, like -4 and 10. Oh shoot, I didn't want to make that a 10. I wanted to make it a y. Let's see. negative, and positive. Then in quadrant 3, every point will have a negative x and a negative y. Quadrant 4 will have a positive x and a negative y. And you can look at a point. Once you memorize these quadrants, you can look at a point and tell which quadrant it lies in just from its coordinates. Also notice any point on the x-axis will always have a 0 in the y location, the y coordinate. It means it's going to have some number for x, but it's always going to have a 0 for y. Any point on the y-axis is going to have a 0 for the x and then any number for the y coordinate. We'll talk about that later a lot more. Now we want to determine whether an ordered pair is a solution. This is from example 5 in your textbook on page 174. What we're going to do is plug in these x values, that are x and y values, in the points to see if they basically fit in this equation, if it makes the statement a true statement when you plug it in. In other words, this is in part A, we have an x value of 0 and a y value of 12. We want to see if we plug a 0 in for x over here in the equation and a 12 in for y, will we get a true statement? So let's try it. 3 times x, but x is 0, minus 12. Does that equal 12? Let's see. Well, 3 times 0 is 0. Minus 12 equals 12. Now, does negative 12 equal 12? No, that's not true. So this particular point does not satisfy the equation. It's not a solution to that equation, which means that that point is not on this line. If you were to graph this line on a coordinate system, that particular point, 0, 12, would not be on that line. What about 1 and negative 9? The x value is 1, so we have 3 times x. X is 1 minus y. But what is y? Negative 9. Be careful here, because you have a negative in the equation, but you have a negative as the value of y. So we have 3 minus negative 9 becomes plus 9 equals 12, and then 12 does equal 12. So this checks out. So this particular point is on the line. It does satisfy the equation. Now for this equation, x plus 3y equals 6, we want to determine if the following ordered pairs are solutions. So that means you have to plug in the x value where there's an x and plug in the y value where there's a y and see if the resulting equation is a true statement. So for x plus 3y equals 6, we're going to plug in 3 for x plus 3y, but y is 1. Does that equal 6? Well then, yeah, we have 3 plus 3, which is 6, equals 6. So yes, this is a solution. Then we have x plus 3y equals 6. We're going to plug in 6 and 0. X is 6 plus 3y, but y is 0. Does that point lie on that line? That means it's a solution. Does that equal 6? Yes, because 6 plus 0 is 6. And negative 2 and then 2/3. Well, let's see. If x is negative 2 plus 3 times 2/3, that's y. Does that equal 6? Well, we have negative 2. Then the 3's cancel. We have plus 2. Does that equal 6? Well, 0 does not equal 6. So this one is not a solution. The second one is, and the first one is. Now we're going to complete ordered pair solutions. We're going to complete them so that it is a solution to the equation. Now here, this equation that we're going to use is x plus 2y equals 8. And what we're going to do is, here they're going to give you either an x value or a y value, and you're going to solve for the other value. With the first one, we're giving you a 0 for x. Then you have to solve it for the corresponding y. The second, we're giving you a y value. You have to solve it for the x. Third one, we're giving you an x, and you're going to solve it for the y. So how do we go about this? We just plug in the value for x. For the first problem, gives you x equals 0. So the equation is x plus 2y equals 8. So I'm going to plug in a 0 for x. 0 plus 2y equals 8. So that means 2y equals 8 and y equals 4. So 4 is the corresponding y value that goes with that particular x. We're forcing ourselves to find what the coordinate, the ordered pair is that falls on this particular line. The next one, we're given the y value. So the equation, once again, is x plus 2y equals 8. And we're given a 3 for the y. So x plus 2 times 3 equals 8. So that's x plus 6 equals 8. Subtract 6. So x equals 2. That's the corresponding x value. So we've completed the ordered pair. With the next one, we're going to do the same thing. So x plus 2y equals 8. We're given the x value now, so that's a negative 4 plus 2y equals 8. And let's add 4 to each side. So 2y equals 12. So y equals 6. So 6 is the corresponding y value. These 3 points all lie on this particular line, x plus 2y equals 8. And you have completed an ordered pair. Here we're going to do the exact same thing, but it's in table form. You're going to be given an equation and asked to form a table of x values and y values. All we're doing is completing an ordered pair, just like we did in the previous example. It's just that it's in table form. So the equation is given up here, y equals negative 2x. So in this case, we're given an x value of negative 3. We have to solve for the y value. So let x equal negative 3. So that means we're going to plug a negative 3 in our equation. So y equals negative 2x. But what is x? X is negative 3. So that means y equals negative 2 times negative 3 is 6. That is our corresponding y value. The next one, we're going to let y equal 0. And we're going to plug in a 0 for y. So our equation is y equals negative 2x. But we say y is 0, so we put 0 there. And we solve it. We divide both sides by negative 2. And we get 0 equals x. So x is going to be 0 as well for that point. Then we let y equal 10. So y equals negative 2x, but y is 10 equals negative 2x. We divide by negative 2. So we have a negative 5 equals x. And now we have 3 coordinate pairs. We have 3 ordered pairs. The first one is negative 3 comma 6. The second one is 0, 0. The third one is negative 5 and 10. All three of those points will lie on that line, y equals negative 2x. I'm going to complete this other table. Given this equation, y equals 1/2 x minus 5. First, we're going to let x equal negative 2. So we're going to plug in a negative 2 in the equation. So y equals 1/2 times negative 2. That's our x minus 5. So y equals, well, 1/2 times negative 2 is negative 1 minus 5. So y equals negative 6. Okay. Then we're going to let x equal 0. So y equals 1/2 times 0 minus 5. But 1/2 times 0 is 0. So y equals negative 5. Then we let y equal 0. So we put 0 equals 1/2 x minus 5. Then if you want to, you can add 5 to each side. And we have 1/2 x equals 5. And then we can multiply both sides by 2 to get rid of the denominator there. Okay, so the 1/2 times 2 cancels. We get x equals 10. So our ordered pairs are negative 2, negative 6, 0, negative 5, and then 10, comma 0. Those are 3 points that lie on the same line. Here we want to complete this table for the given equation. We have 2x plus y equals 4. Well, we're going to be given one coordinate value and asked to solve it for the other one. So for this one, change colors there. Let's plug in 4 for y. So that means we have 2x plus 4 equals 4. Now remember, we're solving to find the x value, so we need to get the x by itself. So let's subtract 4 from each side. That gives us 2x equals 0. Divide by 2 on each side, so x equals 0. All right, now when x is 2, we have 2 times 2 plus y. Remember, we're plugging it into the same equation, equals 4. So now we're solving for y. So we have 4 plus y equals 4. Subtract 4 from each side. Then we have y equals 0. So when x is 2, y is 0. Now, when y is 2, what is the x going to be? Well, let's see. We have 2x plus y, but y is 2 now, equals 4. Sometimes you can see it happening. So let's subtract 2. So 2x equals 2. So x equals 1. So these 3 points are solutions that we are points that lie on that line. Here we're going to talk about graphing linear equations. Now, we just introduced the coordinate system and talked about where these points lie and everything. Now we're going to talk about identifying linear equations. I'm just going to read this. Just pay attention. We looked, well, I'm not going to read the whole thing, but in the last section we looked at equations, the fact that equations can have more than one solution. In fact, an equation of a line is going to have an infinite number of solutions, because if it's a line goes on forever and ever, and it has an infinite number of points on the line. That's something that's kind of hard to understand, that a line has an infinite number of points. That's not saying that every point that you can name is on a line, but that means that every line has an infinite number of points that can be identified. All right, so the example that's given here in this objective 1 is the equation x minus 2y equals 6. And it says that both 6 comma 0 and 2 comma negative 2 are solutions to that equation. That means if you plug 6 in for x and 0 in for y, you're going to get a solution. If you plug 2 in for x and negative 2 in for y, you're going to see that it is a solution. But this equation has an infinite number of solutions. Any x value that you plug in to the equation is going to give you a y value as an output. And if any y value you plug in is going to give you an x value. So it's an infinite number of points. That's why when we graph those points, they form a line. And because this line goes on forever and ever, we always indicate that by putting arrows at the end of the line. All right, so that when we plot several points and connect those points with a line, we say that that line is the graph of the equation. So down here, we have the graph of the equation x minus 2y equals 6. It's the same points that were plotted up here are plotted down here, but then they have just been joined together to create a line. And that's how lines work. You plot the points, you connect them, and you draw arrows at the end. Now, because this is a linear equation, that means the graph of it is a line. So we're going to be graphing linear equations in 2 variables. These equations have 2 variables, x and y variables. And the graph of every linear equation in 2 variables is a line. You're going to get much more information on this as we move ahead. The form ax plus by equals c. Notice that you have a variable x and a variable y. The a, capital A, is the coefficient of the x term. The b is the coefficient of the y term. And c is a constant. When an equation is in this form, it is called standard form. This linear equation is in standard form when the x term and the y term, this is the x term, this is the y term, when they're both on the same side, on the left side of the equation, and it's set equal to c. Now, notice that the x has an understood exponent of 1. Remember, when you don't see an exponent with a variable, it's understood to be a 1. And the y has an understood exponent of 1. The fact that these have exponents that are not greater than 1, or that are 1, means that this is a linear equation. It means that when you graph it, it will be a line. It won't be a circle. It will not be a parabola or something else like that. It will be a line. It's very important. If you see in an equation a variable raised to another power other than 1, it is not a linear equation. Okay? Now, let's determine if each of the following is a linear equation in 2 variables, and if it is in standard form. Okay, now keep in mind, standard form is ax plus by equals c. An equation does not have to be in standard form. It's just that if you can write it in standard form like that, then you know it is a linear equation in two variables. Let's look at number 1. This equation, 2x plus y equals 8. Is this a linear equation in two variables? Well, all you have to look for is the exponent on the x and the y. If the exponent on the x and the y are both 1s, then this is a linear equation. So this is a yes. Is the equation in standard form? Is it in the form of ax? Yeah, here we have an x term here and a y term here and a constant over here. So it is in standard form. All right, number 2. Is it a linear equation in two variables? You have an x term with a 1 as an exponent, a y term with a 1 as an exponent on the y. So it is linear. Now, is it in standard form? Are both your x term and your y term on one side and on the left side and the constant is on the other? No, it's not. But if we wanted to, we could put it in standard form easily by just doing this, writing negative 2x. Bringing the 7y over to the left side would make it minus 7y equals 0. Now, we weren't asked to do that, but I'm just showing you how you could put it in standard form if you had to. All right, look at number 3. Is it a linear equation, two variables? The exponent on the y is a 1. The exponent on the x is a 1. So it's linear. Is it in standard form? Are the x term and y term on the left-hand side and the constant on the right? No. Okay. Now this one, number 4, y equals 7. Is that a linear equation in two variables? Well, on first sight, it looks like it's not, but it actually is, because, see, a linear equation is an linear equation if it can be written in the form ax plus by. Can this be written in the form ax plus by equals 7? Well, yeah. Well, the only thing is that our x would have a 0 as its coefficient. 0x plus y equals 7. Look at that. The coefficient of the x term is 0. The coefficient of the y term is 1. Right? So it can be written in standard form, which means that it is a linear equation in two variables. It's just that that x value has been removed because of its coefficient being a 0. Be very careful with these. So it is a linear equation. And is it in standard form? Well, no, because we don't write the 0x term. The next one is x plus y squared equals 9. Well, the first thing, is it linear? Well, the exponent on the x is a 1, but the exponent on the y is a 2. So right there, that lets you know it's not linear. No, and it's not in standard form. X equals 5. Is that a linear equation? It actually is, because it can be written as x plus 0y equals 5. Okay, it can be written, so it is linear, but no, it's not in standard form. Now we're going to graph linear equations by plotting ordered pairs of solutions. All right. We're approaching the end of this video. Got a few more slides to go. Let's graph this one. 2x plus y equals 5. Now we're going to find 3 ordered pairs, and we're going to choose any x value for x or y, any value for x or y, and then solve for the other variable. Please note that if you're someone else doing this might choose different points. You make strategic point choices for yourself. What I like to do is choose one positive coordinate, a negative coordinate, and a 0 to help me solve it, if that's going to help me, to graph this thing easier. So I'm going to choose, let's say if I choose x is 1. If this is going to be my x value, this is going to be my y. If I choose x to be 1, if x is 1, plugging it into the equation, what is y going to be? 2 times 1 plus y equals 5. So that's 2 plus y equals 5. Y equals 3. So 1 comma 3. Then I want to do, well, let's see if x is 0. If x is 0, then what is y? If x is 0, then the 2x term goes away. Because this is 0, it's going to go away. So if x is 0, y is what? Y is 5. I hate the way that looks. Y is 5. What about if x is negative 1? Let's see. We have 2 times negative 1 plus y equals 5. So that's a negative 2 plus y equals 5. And then we add 2. Y equals 7. So let's see. If I didn't make any mistakes, we have 3 ordered pairs now. We have 1 and 3, 1 comma 3. So on this coordinate plane over here, I'm going to plot 1 and 3. 1 to the right and 3 up. That's 1 and 3. Then 0 and 5. 0 in the x direction, 5 in the y is up here. Actually, those 2 points are enough for me to graph a line. But we always do 3 points to check. Make sure we don't do any algebra wrong. So negative 1 and 7 will go up here. Do you see how we got 3 points? Now we can draw a line. Let me see if I can get me a line going here. And so we have a line. That's the graph of the line 2x plus y equals 5. And all we did was find points, choose 3 points. Now you could have chosen any other points. I want you to understand that you could have chosen other points. For instance, I won't be able to erase it, but you could have chosen if x is, let's see. You could have chosen if x is 3, y would be what? Let's see, x is 3, that would give 2 times 3 is 6, plus what gives you 5, negative 1. 3 and negative 1. If you had chosen 3 for x and come up with a negative 1, well, that right? Look at 3 and negative 1. It's down here. See, I just plotted that point right there. So it's on our line. Any other point you choose would have given you a value. So everybody doesn't have to choose the same points. You're going to get the same line. We're going to graph this next equation. Let's get some x and y values. So we're going to choose some random numbers now. I'm going to let x equal 0. I don't want that to be blue. If x is 0, what is y going to be? Let's plug in a 0 for x. This one I'm not going to do it. I'm just going to show you you can just block out the x term, because if x is 0, this term goes away because anything times 0 is 0. So then we have 3y equals 15. Well, 3 times what is 15? Well, 5. Okay, so 0 and 5 is one coordinate pair, ordered pair. Then what about if we choose y is 0? If y is 0, then this term goes away. So we have negative 5x equals 15. Right? Negative 5 times what is 15? Negative 3. Okay, what if x is, say, negative 2? So if we have negative 5 times negative 2 plus 3y equals 15. We're just plugging negative 2 in for x. So that's 10 plus 3y equals 15. 3y equals 15 minus 10 is 5. So y equals 5 divided by 3, or 5/3. Cool. Well, we have 5/3 here. Okay, so let's plot these points. 0 and 5 goes 0 and 5 goes here. Negative 3 and 0 goes here. And then negative 2 and 5/3. So see, 5/3 is what? 3 goes into 5. 1 and 2/3. 1 and 2/3. So that's 2/3 of the way between 1 and 2. So negative 2 and then 1 and 2/3 is roughly about here. Okay? Let's connect them with a line. So I connected it with a line, and that's all you have to do. Now make sure when you're graphing these that you purchase some graph paper. You don't need tons of it, but you need a pack of graph paper to do these graphs, and you need something straight to draw your lines. Do not try to wing your lines freehand. Always use something straight, a ruler or an ID or something like that that has a straight edge. Graph this equation, y equals 3x. By plotting points, we're going to make a table x and y of x and y values. Well, let's see. Let's use x. X is 0. That's an easy one. If x is 0, then what is y? Y is 0. If x is, say, 2, what is y? Y is going to be 3 times 2, which is 6. If x is negative 2, then y is, in this case, negative 6. So we have 3 points. We can plot them. 0, 0 is the origin. 2 and 6 is here. Negative 2, negative 6 happens to be here. So this line goes through the origin. We can graph it. So here we've graphed it, and you can see that that forms a line going straight through the origin. Now we're going to graph the linear equation y equals 1/3 x plus 2. We are not given any coordinates, so we're going to have to choose our own points. So, keep them simple, keep them easy to calculate. So if we choose, if this is our x and this is our y, let's see what happens if x is 0. let's see what happens when x is 3, and then see what happens when x is negative 3. I'm choosing that because I see that the denominator of that coefficient, negative 1/3, is a 3. So if we multiply that, if we put a 3 in or a multiple of 3 in for x, that's going to make solving for a particular point really easy. So if x is 0, then what is y? Y equals negative 1/3 times 0 plus 2. So y equals 2. When x is 0, y is 2. When x is 3, y equals negative 1/3 times x, but x is 3 plus 2. So what happens? The 3 cancels here with the other 3, so y equals negative 1 plus 2, so y is equal to 1. So when x is 3, y is 1. Now what happens when x is negative 3? Y equals negative 1/3 times x, but x is negative 3, and then it's plus 2. So the negative and the 3 cancel, so we have y equals 1 plus 2, which is 3. I don't want to put it that color. All right, so we can plot these points, 0 and 2. That is 0 in the x and 2 in the y. It's right here. 3 in the x and 1 in the y is right here. Negative 3 in the x and 3 in the y goes here. And when we connect the dots, we get this line as it appears here. Now look at this one, x equals 3. This is a linear equation, and it is a linear equation in 2 variables. It's just that you don't see the y variable because the coefficient of y is going, and it's in this case is 0. So anyway, we have x equals 3. What does that mean? What that means is no matter what y is, what value y has, the x value is going to be 3. So that means if y is 0, x is 3. If y is 2, x is 3. If y is negative 2, then x is 3. Now, this, if you graph it, looks like this. 3 and 0, 3 and 2, 3 and negative 2. Now look at this line. This you can see is going to be a vertical line. And it's a vertical line that goes through the point where x equals 3. So every vertical line has an equation that looks like x equals some constant. You know, x equals negative 5 is a vertical line going through negative 5. X equals 152 is a vertical line going through 152 on the x-axis. So you're going to have to remember that. But if you can't right away remember it, make a table and understand when it says x equals 3, that means no matter every point on that line has an x value of 3. This one I want to do 2 lines on one coordinate plane. So you can, that's not right, x and x, I want x and y. So you can see these 2 graphs and compare them to see if you notice something about them. All right, let's do y equals 3x plus 6. Let's choose some points here. I'm going to choose 0, if x is 0, y is 6. If y is 0, x will have to be, let's see, 3 times negative 2. Then let's see, if x is 1, y is going to be 9. Then for the other one, if, let's see, x is 0, y is 0. If x is 2, y is 6. Let's say if x is negative 3, y is, I'm just choosing numbers close to 0 so we can have enough room to graph it. If x is negative 3, y is negative 9. I want to show you something. I'm going to plot these points. The blue 0, 6 is here. Negative 2, 0 is here. 1 and 9 is here. Okay, do you see that? Then 0, 0, 2 and 6, negative 3, and negative 9. Give me 1 second. So I just drew these lines. Now, what do you notice about these two lines, other than one is pink and one is blue? Did you notice that the slant of these two lines is equal? They both have the same incline, which means they are parallel to each other. Now, what's different about them is it relates to the equation. Notice one is y equals 3x. This one is y equals 3x plus 6. Okay, so that graph has shifted. It has shifted the graph. That add at plus 6 has changed the location of the line, but it has the same exact slope or exact slant. I want you to keep that in mind for when we get to the next section.